Hello, my name is Talia and I'm a designer on the Apple design team. Today we will learn what's new in SF symbols. The value of symbols as one of the elements of user interface design cannot be overstated. They are the simplest form of communication between the user and a product and serve as little pieces of a puzzle that aid in usability and intuitive navigation. They also make interfaces faster to use, helping us navigate quickly as most symbols are language independent. They can help communicate content or help trigger a specific action, and many times, symbols help solve quite a few complex or abstract concepts. SF symbols bring this all together in a library of iconography designed to integrate seamlessly with all the San Francisco font families, providing a powerful and flexible design resource for creating experiences on all Apple platforms. Today, we're going to have a quick recap of the SF symbols basics. The repertoire keeps growing, so we will take a look at some of the new symbols additions. We have expanded the localized symbols by increasing the script coverage. We will look at those in localization. We will study the anatomy of a symbol and learn how its structure makes color possible. We will discover the benefits of adding colors to symbols in rendering modes. And finally, we got some exciting updates to the SF Symbols app and the color library. So let's get started. Each symbol comes in a wide range of weights that automatically align with text labels. In iOS, SF Symbols supports dynamic type and the bold text accessibility feature. SF symbols are also available in 3 scales: small, medium, and large. These scales maintain the same point size, changing only their scales, with stroke thicknesses that are optically adjusted and weight matched with the text. You also need to be aware of 2 different alignments. First is the vertical alignment. Symbols are automatically vertically centered to San Francisco's cap height in all the different scales and weights. And as you may know, some symbols have negative margins. These margins are there to aid with horizontal alignments. That is the case for most variants with badges, for example. When displayed in the UIs, symbols will be horizontally centered, giving a consistent look, especially when displaying similar symbol variants. If you want to learn more about all the features in SF symbols, last year's session from WWDC21 will get you up to speed. Now let's talk about symbol variants. A symbol is defined as a representation of a symbolic value that is used for the purpose of communication. For example, the word love is represented by a heart. In UIs, a symbol is part of a visual system that conveys meaning. To enrich this communication system, a symbol with the same representation can come in many different forms. In SF symbols, the default or universal variant is the outline version of a symbol, as it relates to the typography in the way that we can imagine the same tool drawing the symbol and the text. In the absence of context, outline is the default. And when we want to make a symbol more prominent, like when we wanted to have more surface area to saturate with color for the purpose of selection, the filled variant is a great choice. In SF symbols, a symbol may come in many different forms. We have outlined and filled variants. We also have slash variants, which are used to convey the functions of removing or displaying an item as inactive or unavailable. We have enclosing variants that are contained inside a shape like a circle, square, or rectangle. All these variants help make the UIs richer and give more flexibility when setting up visual hierarchies with the interface elements and the content. A clear visual system will go to great lengths in reducing the appearance of complexity, even when the actions themselves are complex. Consequently, knowing where to use a symbol variant is essential. A filled symbol in swipe actions and iOS tab bars give a consistent appearance and level of emphasis, giving better control in areas that indicate selection when defined with an accent color. A symbol inside a circle with a filled variant provides better legibility at small sizes. And an outline or default variant of a symbol is great for toolbars, navigation bars, lists, and other places in the UI where symbols are presented alongside text or where symbols need to display a uniform appearance. When designing your own symbols, remember to be consistent and define a system that meets the user's needs. In this way, you will help perceive visual metaphors that are directly related to the actions that the symbols initiate or the content the symbols represent. As symbols become available on all platforms, the SF Symbols library keeps growing, with nearly 600 new symbols available this year. We have expanded the Apple products and devices. And we have new additions for video game controllers. We have some health-related symbols, with plenty of new symbols to represent communication, and new inset symbols that are helpful for designs related to interface layout and window management. We also designed some symbols for watchOS, and we have many new objects to choose from, making SF Symbols a library with more than 3,000 symbols to choose from. Now, let's talk about localization. At Apple, we seek to make interfaces more inclusive and tailored for international and multicultural audiences. This year, we have expanded the SF Symbol script coverage with new symbols for Arabic, Hebrew, and Devanagari, and included designs for Thai, Chinese, Japanese, and Korean. We made it easy by making all these localized symbols and script variants adapt automatically based on the user device language, including right-to-left writing systems. If you're designing for left-to-right and right-to-left writing systems, consider the directionality and overall look of both localized variants, and be aware that in some cases, some symbols will not have the intended look when mirrored. In this case, a new design tailored to the specific script's needs will be needed, like in this example. If you want to learn more about designing for right-to-left writing systems, check out the Human Interface Guidelines. Now, let's study the anatomy of a symbol. Every symbol starts with a vector point. From there, we can draw two types of segments, straight lines and curves, also known as Bezier control points. We define the design source of a symbol by drawing a path as a completely enclosed shape. Then, we get to expand the stylistic range by drawing additional sources and making sure that the design sources are point compatible. That is, each source has the same number of vector points. Next, we interpolate the design sources, creating instances that give us the different weights and scales. So as you can see, drawing with closed paths is really important in order to achieve consistent shapes, which allow us to have a lot of flexibility when creating a symbol. If you want to learn more about interpolation and drawing symbols, check out this year's session, Create Custom Symbols. If you have ever drawn paths with a pen tool, you might be familiar with strokes. Usually, that is the way to give thickness to a path. But for SF Symbols, we do it a bit differently. If you look at it closely, a stroke is a given thickness value assigned to precisely follow a path. Although a stroke can have any thickness, it typically uses the paths at its center. That means that the actual vector points that will define the thickness of the stroke are not reliable for interpolation, as the strokes have no vector points on their borders. To ensure that the drawings are reliable, to facilitate interpolation and better control the shapes, the strokes must be converted to outlines, which can be achieved with most vector graphic editors and design tools. Now that we know how SF symbols are drawn, let's look at their structure and shapes. As you may have noticed, some symbols combine two or more objects, like the share symbol, which is a combination of an arrow and a square. When those objects are combined, we can emphasize one shape while de-emphasizing the other. That way, we can define design strategies with badges and overlaps. We can determine the foreground and background elements in just one symbol, and even create different variants with its different container shapes. There is a lot of versatility. We can even highlight screens. And this is all done with what we call annotations. We group the enclosed vectors of a path like layers inside a symbol. That way, we can quickly identify a primary, secondary, and even tertiary layer of a symbol structure, creating a hierarchy. So imagine all the possibilities. Symbols are getting ready to be displayed in all their glory, but not before we talk about rendering modes. Colors can speak in ways that are as powerful as language. Plus, it is more than just an aesthetic element, as it can affect thinking, helps change actions, and create reactions. As a form of communication, color is compelling. And as you can see, SF symbols become highly versatile when color is applied to them, making them an even more powerful tool. When color is present, the symbols become one of the most essential methods of engaging the user, helping you create a statement or draw attention. This year, we're happy to announce that we have new rendering modes to choose from: Hierarchical and Palette, in addition to Multicolor and Monochrome. First, let's look at Hierarchical. Hierarchical rendering mode uses a single color with varying opacities that add visual hierarchy to a symbol, creating depth and emphasis while allowing a single hue to drive the overall aesthetic. When multiple symbols that share common shapes are presented alongside one another, this rendering mode emphasizes the difference between them, intending to make the symbols more legible and recognizable. It also attempts to reduce redundant visual noise by modulating the opacity without removing the essential elements of the symbol. We achieve this by annotating the symbols with a desired hierarchy, considering the primary, secondary, and in some cases, the tertiary element of a symbol. When a base color is applied to a symbol, it is automatically applied to all the layers in the hierarchy, using different opacities to emphasize the key characteristics of the symbol. Let's analyze these symbols again, now with the hierarchical rendering mode. Some symbols have all the hierarchy levels. This symbol with a cloud, sun, and rain is a good example. But one important thing to know is that most symbols don't have all these three levels. This is due to the nature of their designs. Let's focus on these symbols. Shapes that don't touch or have a gap between the first and second element of a symbol are considered secondary, while shapes that do touch and are encapsulated inside one another, like the field, circle, or the screens shown in these examples, become tertiary. With hierarchical rendering mode, we can achieve more robust interfaces with just the emphasis on hierarchy and color. We saw what we could do with hierarchical. Now with Palette, we have even more possibilities. As we learned, the hierarchical rendering mode uses a single color. In contrast, Palette rendering mode gives the possibility to use two or more contrasting colors, each of which can be controlled independently, giving elements of a symbol more prominence, emphasis, and versatility when color is applied to them. Additionally, Palette rendering mode has opacity controls that give us even more possibilities, allowing for symbols to be customized to better integrate with the UI's overall look. This rendering mode relies on the same layer annotation data as hierarchical. If only two colors are applied to it, the tertiary layer group replicates the secondary layer annotation. So remember this when annotating your own symbols. In Palette rendering mode, a set of symbols can have the same defined color palette applied to them, helping the user identify a group of symbols with the same level of functionalities. In contrast, a similar set of symbols can each use unique colors to define a particular functionality, reinforcing the actions of the symbol and making them more distinct between one another. With Palette rendering mode, you can bring contrast and versatility to your symbols. Now, let's talk about Multicolor. Multicolor is a rendering mode that represents the intrinsic or native color of a symbol. That means it uses a multitude of different colors that relate to the appearance of an object in the physical world, or it conveys meaning between a concept and an assigned color, like in this example. The concept add is linked to the color green, and the concept removed is linked to the color red. Many symbols feature this intrinsic color palette, which is what's rendered by default. When customized, each color can be assigned an arbitrary one. With multicolor symbols, you can emphasize the symbol's identity, creating a stronger color narrative that associates with a symbol's forms. There are a few ways in which multicolor can affect a symbol. A symbol can be fully colored. A symbol can be partially colored, which means that part of the symbol will have multicolor feature, while the other will rely on an accent color. And finally, if a symbol does not contain any multicolor information, it will render in monochrome. This year, we are introducing several new symbols with multicolor functionality. The range of colors from which this draws is limitless. And lastly, we have monochrome. Monochrome is the rendering mode that most closely reflects the typographic nature of SF symbols. Color-wise, it is neutral as it accommodates for symbols to commingle with one another without emphasizing one over the other. Monochrome also benefits from color and opacity controls, but the difference with other rendering modes is that in monochrome, the opacity is applied to all the symbol without making use of the layer annotation data. When uniformity is of first importance, monochrome is ideal as it is the most unified and consistent rendering mode. Next, let's talk about the SF Symbols app. This year, we made significant changes to the SF Symbols app. As we have seen, we have all the new and improved rendering modes: monochrome, hierarchical, palette, and multicolor. To access all these colors for the rendering modes, we have the color picker. Here you can choose from the existing color library, select the system accent color, or even define your own custom colors. And indeed, all colors shown in the SF Symbols app are all available on all platforms. We also have some updates to the color library in light, dark, and increased contrast appearances, with some colors adapting depending on the platform. As a result, some platforms will get new colors that were previously only available on other platforms. For example, brown, previously only available on macOS, is now available on all platforms. We also redefined teal with a greener hue to reflect its visual representation more accurately. Cyan is a new color name that will use the previous teal color values. If you were previously using teal, you will need to switch to the color cyan to maintain the legacy appearance. Additionally, indigo and purple are available on all platforms with more consistent hue definitions. From rendering mode selection to color customization, SF Symbols is an extremely powerful tool to use when implementing symbols in your UIs. If you want to learn more about the SF Symbols app, check out this year's session, Explore the SF Symbols free app. So let's recap what we've covered. We have a new version of the app that is now available for download. We have hundreds of new symbols. You can find the new beta version of the SF Symbols app in developer.apple.com/sfsymbols. We talked about variants, and we had a quick recap of the SF Symbols basics. We have new script coverage for localized symbols and new symbols adapting to right-to-left writing systems. We learned about the anatomy of a symbol and how drawing with vector points and paths can make layer annotation possible. We talked about color with some awesome new rendering modes, hierarchical and palette, and we reviewed more in depth the multicolor and monochrome modes with all their amazing features. Remember that all rendering modes adapt dynamically with Apple Platform system colors. This automatically adjusts to vibrancy, accessibility settings, and appearance modes. These rendering modes work with custom colors as well. And we saw the new SF Symbols app and learned about all the color library updates. This year, SF Symbols becomes more powerful, flexible, and configurable, tailored to suit your needs. One symbol in 9 weights with 3 scales each, in 4 rendering modes. That is amazing. I hope you enjoyed learning about what's new in SF Symbols. We can't wait to see what you will do.